Lesson 2.7, or 2-7, depending on what you want to call it, is the inverse variation model. So when y equals k over x, we say that y varies inversely as x, which sounds really goofy. Another way to say it is that y is, sorry about that, y is inversely proportional to x. K is called the constant of variation, or sometimes the constant of proportionality. And cannot be zero. Sometimes you'll see the expression k over x written as kx to the negative 1. Just keep in mind they're the same. So these types of graphs are called hyperbolas. They have horizontal and vertical asymptotes at y equals 0 and x equals 0. And so when our k is greater than 0, our graph will show up in quadrants 1 and 3. And when k is less than 0, our graph will show up in quadrants 2 and 4. So we have a chemistry lab, I guess, and you're collecting data on the pressure and volume of a gas, and pressure and volume vary inversely. So when you hear vary inversely, you know you're going to use y equals k over x, okay? So let's say, in this case, we're going to use v and p, but if it makes more sense to you, you can just label them x and y. So v for volume, p for pressure. If pressure and volume vary inversely, then we know that p equals k over v. Keep in mind it would be equivalent to say v equals k over p, but for part A here, we're finding a formula for pressure in terms of volume, so that's why it's p equals. So to do that, we have to kind of come up with an average point. And so if we're going from 20 to 100, 20 plus 100 over 2 is 120 over 2, which is 60. So our approximately average point is right here. Just want to pick one somewhere in the middle. So then we'll use that. And so if P equals K over V, then our pressure of 84.6 equals K over our volume of 60. And then we're solving for K. So if we multiply both sides by 60, this fraction will just go away. So K is 60 times 84.6, which is 5,076. Calculator work, I didn't just automatically know that. And so then our equation for P equals K over V, now that we have our K, we have P equals 5,076 over V. And so now we can use that equation to answer part B, what volume corresponds to a pressure of 40 kilo something. I'll be perfectly honest, I don't know what that means. Probably one of you does. And if not, that's okay. But it's just in terms of, I'm sorry, I managed to switch back to 2.6b for a second. Okay, so we use P equals 5,076 over V. I'll just rewrite it just because. And now we're looking at a pressure of 40. We'll just ignore the units for now. So that means 40 equals 5,076 over V. And then we're going to solve for V. So first, we're going to have to multiply both sides by V, because it's on the bottom of a fraction, and that's not going to help us much. So multiply by V on this side, fraction goes away. On this side, we have 40V equals 5,076. And now we can solve for V. Divide both sides by 40. And V equals 126.9 milliliters. That unit I know. Okay? Now we have another one. This is obviously very old. I don't know if you guys even know what MP3 players are, but you used to be able to put songs on MP3 players or on iPods, and now everything's just kind of around. But we used to have, 32 gigabyte MP3 players, I guess. I think I ever had one though. I did have iPods. Moving on. So we have average song size. I'm going to say song size is S. You can call it whatever you wanted. Average number of songs, I'm going to call that N for number of songs. And we want to find an inverse variation formula that gives the average number N songs that will fit in an MP3 player as a function of S. So that means if N is a function of S, we're going to have N equals K over S. That'll be our general formula, okay? So now we have to find an average point again. So it looks like our lowest is 3.6 or smallest as far as average song size, and our highest is 5.8. So you find the average, 3.6 plus 5.8 over 2, you get 4.7. That's about our average point, so I'm going to use this one, okay? So now N equals K over S, that means 7,000, using that average point we just found, will equal K over 4.7. Multiply both sides by 4.7, we have 7,000 times 4.7 is equal to K. 7,000 times 4.7 is 32,900. So then back to our general formula, we had N equals K over S. So now we have N equals 32,900 over S. So there's our formula. And so in order to have 8,500 songs on your MP3 player, what must the average song size be? So we use our formula, N equals 32,900 over S. So then N is our number of songs is 8,500, must be 32,900 over S. Multiply by S on both sides. 8,500 S is going to be 32,900. Solve for S, which is our average song size, divide by 8,500. So S will be 3.9 megabytes. In science context, hang on, the highlights, we don't forget about this piece, doesn't get lost. In science contests, not contests, as much as that would be fun, the relationship y equals k over x squared, or y equals kx to the negative second is very common. And these are called inverse square relationships. Sorry, I'm trying to get it to move and it's not doing it for me for some reason. So the graphs of y equals k over x squared, if k is greater than 0, our function will show up, the graph will show up in quadrants 1 and 2, and if k is less than 0, show up in quadrants 3 and 4. So the force exerted by the electrical field between two charged objects is inversely proportional to the square of the distance between them. Whoa, that's a lot. But what I notice is inversely proportional to the square. That means we'll have y equals k over x squared. But in this case, the force, so we're going to call that F. F equals, it's inversely proportional, so we're going to have a k to the square of the distance. I'm going to call that d squared. Square of the distance will be d squared. So we have F equals k over d squared. You could use other variable names. You could use x and y if you want. And we know that at a distance of 1.5 meters, the force is 30 newtons. So then 30 equals k over 1.5 squared. So 30 equals k over 2.25. And now to solve for k, we'll multiply by 2.25 on both sides. So 30 times 2.25 is k, because these will cancel on that side. So k is 67.5. So then our formula is F equals 67.5 over d squared. And now we want to know the force at a distance of 3 meters. So D is 3. So F will be 67.5 over 3 squared. And this ends up being 7.5 newtons. Pause the video for as long as it takes for you to do this next example. Okay, I'm assuming you paused it and then you came right back, or you're like, I don't get it yet, and that's totally okay too. So the intensity of light from a point source is inversely proportional to the square. So I know I'm going to have a y equals k over x squared kind of situation. But now we have intensity is inversely proportional to the square of the distance. So I equals k over d squared. That's our general formula. Suppose that at a distance of 5 centimeters, the light intensity is rated at 600 lux. What's a lux? I have no clue. It sounds made up. But we do know that our general formula is I equals k over d squared. And when the intensity is 600, we'll have 600 equals k over, our distance is 5, so 5 squared. So 600 equals k over 25. Multiplying by 25 on both sides gives us 600 times 25 equals k, or 15,000 equals k. So now our formula is I equals 15,000 over d squared. So now we have a question to answer. What will the intensity be at a distance of 10 centimeters? Well, I equals 15,000 over our d, which is 10 squared, which is 15,000 over 100. And if we're doing that, we can really just cross out 2 zeros on the top and bottom. Cross, 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 cross. We get 150 over 1. So we'll get 150 lux. Again, what does that mean? I honestly have no idea, and you don't need to know. All you need to know is how to solve the equations. So just comparing the graphs, don't worry about this too much for now, but just again, notice that the graphs look pretty similar, but with k over x squared, kind of the hyperbolas, both sides are next to each other, versus with k over x, they're across from each other. We'll worry more about the graphs in later lessons.